Our objective in this lesson is to characterize the roots of a quadratic equation. Let's have a review first. See these numbers here? We are going to classify them as two real numbers, not real numbers, rational numbers, irrational numbers, and perfect square numbers. Let's start with the square root of -8. Square root of -8 is not a real number because this will give you an imaginary answer. Next, 95.7, it's a real number and also it is a rational number. Rational number is terminating decimal, just like this one. Next, we have 25, it is a real number and also a rational number. By definition, rational numbers are numbers that can be expressed as a quotient of two polynomials, and 25 can be expressed as 25 divided by 1. 25 and 1 are both polynomials. Also, 25 is a perfect square number because the square root of 25 is positive and -5. Next, let's have 1/3. 1/3 is a real number. And also, it is a rational number. A polynomial over a polynomial. And when you divide 1 by 3, it is a non-terminating, repeating decimals of 3. That is another definition of rational numbers. Non-terminating, repeating decimals. Next is the square root of 64. It is a real number. And the square root of 64 is equivalent to 8. Therefore, it is also a rational number, just like 25. Next, we have pi. Pi is a real number. And also, it is an irrational number because pi has a value that is non-terminating and non-repeating decimal. Next one is square root of -16 all over 4. This is not a real number. Once again, a negative number under the square root symbol will give you an imaginary result. Next, 3 over 5 is a real number and also a rational number. Polynomial over a polynomial. And when you convert this into decimal form, it is a terminating decimal, just like 95.7. Last one is the square root of 29. It is a real number. And it is also an irrational number. Just like pi, it has a value that is non-terminating and non-repeating decimal. Do you still remember this? This is what we call quadratic formula. But do you know that there is a special name under the square root symbol, b squared minus 4ac? b squared minus 4ac is called the discriminant. Let us talk more about the discriminant b squared minus 4ac. It is called discriminant because it can discriminate the possible answer. I have here 3 columns. The first column is the possible values of the discriminant. The second column is the number and nature of roots depending on the value of the discriminant. And the third column is the graphical interpretation of this discriminant. Let's have the first one. If the discriminant is equal to 0, we have one repeated rational number, and the graph crosses the x-axis at one point. Next, if the discriminant is greater than 0 and a perfect square, roots are rational numbers and are not equal, and the graph crosses the x-axis at 2 points. If the discriminant is still greater than 0 but not a perfect square, roots are irrational numbers and are not equal. Still, the graph crosses the x-axis at 2 points. If the discriminant is less than 0, there are no real roots. Instead, we have a pair of complex numbers, and the graph does not cross the x-axis. Let us start describing the roots. First example, x squared plus 5x plus 4 is equal to 0. The first step is to identify the a, b, and c. So our a here is the numerical coefficient of the variable raised to the second power, and that is 1. Next, our b is the numerical coefficient of the variable raised to the first power, and that is 5. And our c is the constant, which is equal to 4. Next, let us solve for the discriminant. So we have b squared. Our b is 5, so we have 5 squared. Next, minus 4 times a. Our a is 1. Times c. Our c is 4. 5 squared is 25. 4 times 1 is 4 times 4 is 16. So we have minus 16. 25 minus 16 is 9. And 9 is greater than 0 and also a perfect square. So we have two roots that are rational numbers and are not equal. Now let's look into the graph of this equation. Notice that the graph crosses the x-axis at 2 points. These are x equals -4 and x equals -1. Roots are rational numbers. These are rational numbers and are not equal. -4 and -1. Next example, 3x squared minus 6x is equal to -2. First, let us convert this into standard form. So let us move -2 to the other side. Now let us identify the values of a, b, and c. So our a is 3, our b is -6, and our c is +2. Now let us solve for the discriminant. So we have b squared. Our b is -6, so we have -6 squared. Make sure you enclose it in a parenthesis. And then minus 4. And then multiplied by a. Our a is 3. And our c is 2. -6 squared is 36. 4 times 3 is 12. 12 times 2 is 24. So we have minus 24. And 36 minus 24 is 12. 12 is greater than 0 but not a perfect square. Therefore, we have roots that are irrational numbers and also not equal. Now, let's look into the graph. So, since this is greater than 0, still the graph will cross the x-axis at 2 points. But these points are irrational numbers. Actually, the values of these points are these two. Notice that these are irrational numbers and also not equal. Next example, 2x squared minus 6x plus 8 is equal to 0. First rule in mathematics, if you can simplify the given, simplify it first. Notice that these three terms here are all divisible by 2. 2 divided by 2 is 1, 6 divided by 2 is 3, and 8 divided by 2 is 4. Therefore, this is also equal to x squared minus 3x plus 4 is equal to 0. Now, let us identify our a, b, and c. Our a is 1, our b is -3, and our c is 4. Next step, the discriminant. So our b is -3, so we have -3 squared. Copy minus 4 multiplied by a, which is 1, and multiplied by c, which is 4. -3 squared is +9. 4 times 1 is 4, and 4 times 4 is 16. So we have minus 16. And 9 minus 16 is -7. -7 is less than 0. Therefore, we do not have real roots. Instead, we have a pair of complex numbers. Now let us look at the graph. So you will notice that the graph did not cross the x-axis. And if you are going to solve for the roots of this equation, these are the roots. Notice the I here. Those stands for complex numbers. And they are pair, one positive and one negative. Another example, 4x squared equals 28x minus 49. So first, let us convert this into standard form. Let us move these two terms on the other side. So we have 4x squared minus 28x plus 49 is equal to 0. Our a is 4, our b is -28, and our c is 49. Now let us solve for the discriminant. Our b is -28, so -28 squared. Copy minus 4 times a, which is 4, times c, which is 49. Negative 28 squared is 784. 4 times 4 is 16, and 16 times 49 is 784. So we have minus 784. So this is equal to 0. Therefore, we only have one root, but it is repeated twice. Let us look at the graph. So you will notice that the graph crosses the x-axis at only one point, and that is 3.5. Now, if you are going to solve this, you will find out that your x sub 1 and x sub 2 are both equal to 3.5. That is why we only have one root but repeated twice. Here is the summary of what we have discussed. Quick tips, I have here possible values of d and their corresponding graphs. So if d is less than 0, the graph will not cross the x-axis. So you do not have real roots, but instead you have a pair of complex numbers. If d is equal to 0, the graph will cross the x-axis once. So your root is a rational number, just one, but repeated twice. And if your discriminant is greater than 0, the graph will cross the x-axis at 2 points. If it is a perfect square, you have rational roots. If it is not a perfect square, you have irrational roots. Now it is time to check your understanding. Pause this video for more time. Let us answer. Number 1, the discriminant here is 0. So we have one rational root but repeated twice. Number 2, the discriminant here is 16, and that is a perfect square. So we have rational roots and not equal. Number 3, the discriminant here is 109. It is greater than 0 but not a perfect square. Therefore, our roots are irrational numbers and not equal. Last one, the discriminant here is negative 11. Therefore, we have no real roots but instead we have a pair of complex numbers. Gets?